Hello guys, how are you guys doing?
Good. How are you?
Fine, thank you. Um, so this week we round up the confidence interval. So as you next week will be our last week. So as you because according to this college, lecture stopped, class session stops on the 9th of May. That's what it said, at least. So next week I will with probably before the 9th we finish test of hypothesis and then the regression. And we will now prepare you for the final exam. All right. Today, let me start by showing you what is expected of you this week. Excuse me. And my class right here is your class. Okay. This is your class. And for my announcement, you see that what we have this week is mainly to complete this chapter and begin the chapter um, test of hypothesis. Then homework is, there's no classwork due this week, no classwork. So we have today is homework 9 due on May 11, and their project. I'm going to put a project probably by tomorrow, put them together then, and so I can start working on it. So their project and homework 9.
I have a question.
Yes, ma'am.
So what is the project going to consist of? Because I don't think I was here when you explained what it would be about.
I haven't explained what it be about yet, but it will be based on this topic that I just finished, confidence interval. I mean, that's we are finishing today. So that's where I will use to design the project. I haven't designed it yet, but it's an individual project. You do it on your own, and then you upload it from the model. Let me see. What is the model again? Model is if you go to the model. Excuse me, sorry. Um, if you click on the model and then scroll down, this is where the project model will be. I'm gonna put it right here. So if you check it now, you see that it is blank. There's nothing there yet. So again, it is based on confidence interval that we are finishing today. All right, let's begin. We have already done the confidence interval last week. I introduced you to confidence interval for the mean when the sample size is large. When we say it's large, we mean that the sample size is greater than or equal to 30 and that the population standard deviation is known. But today we are working on something different. We're working on when we have a small sample where this population standard deviation is unknown and the sample size is small, which means that it's less than 30. For that, we use what we called the student T distribution table. Now, this table have a very interesting history. Was formulated by William S. Cosette, W.S. Cosette. Now, this guy, he's interesting. He's working at a brewery. A brewery, a brewery is where they make beer. This type of beer, they call it ale. So he find out this at that time, there's a lot of competition between companies. This I'm talking about the 18th century, 19th century, where companies fight and almost like they are fighting for the market. So if you have an invention, if you're working for the company and develop an invention, it belongs to the company, and you don't tell the invention to the world or to because the competition, their competitor might take hold of it and then corner the market. So they were told that they cannot give out any invention. They can't but whatever they find while working for the company, they have to keep it within the company. Now, there was this guy, W.S. Cosette, he believed that his invention can help the world. So he decided to publish it. But he published it with a different name. Call it student. That's why we call it student T distribution table. In any case, we're not going to use using the table for this, for finding the critical value. I remember I explained to you in the class how to use Excel to find it. So the critical value will be found using Excel. We'll be using Excel for that, okay? Now this method that we use when the sample size is small is based on what they call degrees of freedom, and the sample size, where the degree of freedom is gotten, where we can get the degree of freedom by saying the sample size n-1. Now, let's show you how to get this critical values, and then we can proceed with the finding the confidence interval. Okay. Now it says find the T alpha over 2. That means find the critical value for the following confidence in levels: 95% confidence level, 99% confidence level with n equals to 10, where n is here, it means sample size. 90% confidence level with n equals to 14, and then 86% confidence level with n equals to 14. Let me change this to n equals 20. Okay. So now the formula, the Excel formula we'll be using for this will be this one here, absolute. First of all, it saves time, and of course it make it easy to remember. Now we're using it, and so what I'm gonna do is to copy, put all this information in Excel, and then we go from there. So we use this formula right here. I'm gonna copy the formula, and I'll take you to Excel, where you see where we can put this. So I'm gonna put the formula in this side of Excel, the text box here, so you can see the formula we are using. Okay, I'm gonna paste it right here. Absolute. Okay. And make it 14. That's the formula we'll be using here. Okay. Absolute. Now, change this to T. Okay. Not this time, but T. Okay. With this, we can now find our confidence. I remember I explained in the classroom that if you're 95% confident, the chance of being wrong is 5%. So your alpha is 5%, which is the same as 0.05 when changed to decimal. If you 99% confidence, the chance of being wrong is 1%, which means that your alpha is 1% or 0.01. Okay. And when you are 90% confidence, your chance of being wrong is 10%. So your alpha is 10% or 0.1, and descend to 86. In this case, your alpha will be 14%, I believe. 100 minus 86 will be 16. Let me see. 100 minus this. Okay, 14%. So your alpha will be 0.14. So with this, we can get the alpha over 2. Remember, alpha over 2. Why alpha over 2? Because, you know, confidence interval have two sides, the lower interval and upper interval, like we did in the class. So you click on this equal sign, click on the alpha divided by 2. Now we can follow that, you know, drag it down, copy this formula down, and it will calculate the rest of them. So you can see my cross, tick cross. When I bring it close, it changes to skinny cross. At that point, you click, hold, and drag to calculate the rest of them. Now the sample size. Now the sample size they told us was as follows. If we go to our main workbook, we have for 95%, let me write this down. For 95%, they still have to use the sample size of 22. For 99%, and let me change this to 11. So it won't be like we're using only the odds. 11.
Excuse me, Dr. Oji.
Yes, ma'am.
Just a quick question. Will you also have a like a video or instructions for the project like you usually do for the
Yeah,
assignment?
yes, of course.
Okay.
I'm
Thank
gonna
you.
do a sample video. That's
Okay.
that's why I haven't put it yet. I haven't got the time to do the video, but I must do it this week.
Okay, thank you.
So yeah, so I'll do a demonstration video and then you follow the direction there. Yeah.
Okay.
So now for 99%, they say use sample size of 11. For 90%, sample size of 14. 90%, 14. And for 86%, use sample size of 20. So we go there and have it right there. And put them all here. Sample size of, and for 95%, I have sample size of 22. For 99, I got 11. For 90, I got 14. For this, I have 20. Now, n minus 1, I mean, sample size minus 1. So equal sample size minus 1. And you press the enter key to give you the 21, and then you can just copy it down. It will calculate the rest. Now, we are ready to calculate the critical values. This is main thing we are looking for here. Critical values here for the T distribution. Again, the formula, the Excel formula to use is equal absolute parentheses T dot IMV parentheses alpha over 2 comma and n minus 1. Okay. Let us do it. Yeah. Well, let me put this person just came in. Heston. It says Heston. I didn't see it here. All right. Okay, I see it now. Yeah. Close. Close. Just coming. All right, let's do it. Let's do it now. You got I'll make sure you really see this. Okay, good. Equals ABS. Okay. Parentheses. Got T dot inverse. T dot INV. Okay, parentheses again. Oh, excuse me, parentheses again. Alpha over 2. We got alpha over 2 here already. I see right here. Click on it, comma, and then click on n minus 1, which is right here. Then close the parentheses, of course, twice. Since you have 2 opening parentheses, you're gonna close it to 2 closing parentheses. Press the enter key. Then, copy it down. You get the rest of them. And usually we have it in 2 decimal places. So we're gonna change it to 2 decimal places. Okay. And that is our critical values right there. Any question on what you just did? Okay, no question. Good. Now, this will refresh your mind. If it is for sample set that is greater than, if you have a situation where we know the value of the population standard deviation, and then we know the population we know that the sample size is large enough. In most cases, even if the sample size is not large, but we know the value of this population standard, the value of the population standard deviation, we can still use the Z value. And in that case, you can use this formula here for finding the critical value for confidence interval. Sorry, not this one. Yes, this is for finding the num dot s dot inverse right here. Let me make it bigger and highlight it. In that case, we use num dot s dot inverse. Then one parenthesis 1 minus alpha over 2. That is if the sample size is large and we know the value of the population standard deviation. But that's not what we are doing now. The one we're doing now is that where the sample size is small, okay, and we don't know the value of the population standard deviation. That case, we use the formula that I just showed you, that we just used in Excel, which is equals ABS parenthesis T dot inverse parenthesis alpha over 2 comma and n minus 1. And we just used it here. Now let us do the confidence interval itself. Look at the question right here. It says that before we do it, let us do let's look at the when to use Z and when to use T. I mean a summary of that. When the population standard deviation is unknown, that's the first situation where we use Z or or T. When the population standard deviation is known, then we can use Z alpha over 2 values, no matter what the sample size is. Now, when the population standard deviation is unknown and the sample size is greater than is large enough, we use a sample standard deviation S, and we can still use the formula Z alpha over 2. Now, when the population standard deviation is unknown, but the sample size is small, that's when we use the T method. Okay. Now let's look at this example. It says a random sample. That's the first question. A sample of 6 college wrestlers has an average weight of 276 pounds with a standard deviation of 12 pounds. Find the 90% confidence interval for the true mean weight of all wrestlers. Okay. Now, if the coach claimed that the average weight of the wrestlers on the team was 310 pounds, would that claim be believable? Now, let us get the summary statistics that the person will do. Sample size is 6, and we don't know the value of the population standard deviation. This makes this, for example, a typical case for using T's distribution method, T method, okay? Because sample size is small, which is only 6 college wrestlers, and what we have here is the sample standard deviation of 12 pounds for the 6th college wrestler, and then sample mean weight of 276 pounds. So let's put this together. The first question they asked us was to find the 90% confidence interval. So for the true mean weight of the wrestlers. Now let's the first small statistics, I'm going to write it on paper and we go and put it there. The first one is sample size, which is 6. Okay. Second one is sample mean, which is 276 pounds. And sample standard deviation, which is 12 pounds. And then we have they want to find 90% confidence interval. So 90% is the confidence level. So let's go and put this in Excel and find the confidence interval. I have here sample size is 6. Sample mean X bar is 276. Sample standard deviation is 12. Confidence level is 90%. It says 90%, so I'm going to put 90% here. 90%. Okay, which is 0.9 basically. Now, we need to find the error margin. Once we get the error margin, we subtract it from the left side to get the lower interval and add it in the right side to get the upper interval. Okay. Now, so I'm gonna put the formula for finding it on the side of here. The Excel formula to use will be confidence.t. We copy it and then place it right here. I'm gonna put the text box here and paste it right there. Confidence.t. Okay. Now let's find the error margin. We have the equal. Type confidence. Now what's type confidence? See, you can see the confidence.t right here. Confidence.t. You can double click on it. Then alpha will be 1 minus this. Alpha 1 minus 0.9, which is a confidence level. Because if you are 90% confidence, your alpha will be 10%. So if there are two ways you can do it. Either you put 10% here, which is 0.1, or you can just use 0.9. So let me just put a 0.1 there. Maybe that will help better. If you're 90% confident that you are this thing, your chance of being wrong is 0.1. Okay. So you have equals confidence.t pops out right here. Alpha, click on this, comma. If you're using this 0.1, then standard deviation is right here, comma. Then sample size is 6 right here. Close it and press the enter key. Give it like this. Now, another way you can do this is if you have let's say that you say 90% confidence, which is 0.9. You put 0.9 here. Okay. Say and do equal confidence dot t. You double click on this alpha, and so because you have 0.9 here, you're gonna do 1 minus 0.9, comma. Then standard deviation is 12, comma. Sample size 6. You see that you get the same result. See? So if you put 0.9 here, you use 1 minus alpha. But if you put 0.1, you use just click on alpha. Okay. Now, like again, let me change it back to what I want it to be, 0.1. In that case, we have equals confidence dot t parenthesis. Click on alpha right here, comma. Then you can see standard deviation, which is right here, comma. And sample size, which is 6. Close parenthesis and press enter key. Now, once you have it, you have your error margin, which is right here. Now you can now get the lower interval by just subtracting the error margin from the mean, equals sample mean of 276 minus the error. Press the enter key, gives you the lower interval, and this here equals to get the upper interval, just add do 276 plus the error margin. Okay, press the enter key. I give you this. I made it all 2 decimal places, and then I'm going to highlight the lower and upper interval with a light blue, and we can go and then conclude. So I have all this. I'm going to highlight it, make it all borders. I'm going to take all this to the, excuse me, sorry. I want to highlight all this, copy it, Control C, and paste it in the Word document so we can now make our conclusion. on the question. Okay. So I'm going to make it right. Place is right here, right below the question, right here. Okay, I'm going to expand it. Make it okay, 16. Okay. Now, remember the question was to find the 90% confidence interval, right? It is right here. Now let's conclude. Our conclusion will be that we are 90% confident. Now I wrote it here because I've solved this question before. That the average weight of all wrestlers is between 266.13 pounds to 285.87 pounds. I see them here. Remember to include the mean, the average or the mean in your conclusion. Otherwise, your conclusion will become wrong. So you have to include the average because it is the mean that you are trying to estimate here. So based on our calculation here, we're 90% confidence that the true mean will be between 266.13 pounds to 285.87 pounds. Now, let's see what we do before I ask that is part B. Part B says, if the coach claimed that the average weight of the wrestlers on the team was 310 pounds, would that claim be believable? Of course, it will not be believable. The answer is no. And why? No, because if you say no, why? Because the interval is between 266.13 pounds to 285.87 pounds. So, but this coach is claiming that the average weight is 310 pounds, which is above the interval. So it doesn't fall within the interval. So because 310 pounds did not fall within the interval of 266 pounds to 285 pounds. Okay? See? Any question on this, guys?
No.
Okay, good. So now let's do number 2. Sometimes I will ask you the question in this form, where, in this one that we just did, I gave you the summary statistics. I told you that the sample mean is 276, and the sample standard deviation is 12 pounds. So I gave you the summary statistics. But here I did not. I just give you a raw data. I ask you to. You say the following data represent the number of I'm going to move this down so we have enough room. Okay. The following data represent represent a sample of the number of home fires started by candles in the past several years. We have 55,460 home fires in this year. And the second year, 5,900 home fires. Third year, 6,090 home, and so on. So find the 99% confidence interval for the mean number of home fires started by candle each year. So to solve this type, you have to calculate the summary statistics by yourself, which means that you have to calculate the mean, standard deviation, and then put the sample size together. See here that there are how many years? 1, 2, 3, 4, 5, 6, 7 years. So let us put the summary statistics together. I got N to be 7 years, and this, I'm going to list these numbers so we can have it. Put it on in Excel to calculate the summary statistics of mean and standard deviation. I got first one I have is 5,460. I got 5,900. I got 6,090. Sorry, yeah, 6,090. 6,310. Got 7,160. Oh, how many of them? Okay, I got 8,440. I got 9,930. 1, 2, 3, 4, 5, 6, 7. Let's go and put it on together. Okay. This is the home fire example. The home fires question. The home fire question. Fires question. So I got numbers in. Let's type the numbers in. I got 5460. Okay, I got 5900s. I got 6090. I got 6310. I got 7160. 8440. I got 939930. So I have how many of them? 1, 2, 3, 4, 5, 6, 7. Now, to be able to calculate the confidence interval using Excel, since we have done it before, I can just copy from here, copy the data set from here. Well, that's good thing about Excel. When you do it the first time, you can just copy it. So as I'm changing this, see the numbers here, I want to watch the lower interval and upper interval because they will be recalculated. For example, now this is 6, 7 number, 7 sample size is 7. Okay. So if I change this to 7, watch now. If I change it to 7, and you see that this will recalculate. So in this case, we don't know the sample mean. You can calculate the sample mean here. Remember the formula for mean, average. So you put equal average. Excuse me. Average. Okay, pops out right here. Double click. Highlight all this. Close the parentheses. Press the enter key. Okay. See, they were calculated now. Sample standard deviation, I'm going to use this again, equals stdev.s. Double click on it and highlight all of this. Close the parentheses, press the enter key, give me the standard deviation. Now we're in the question asks us to do the 99% confidence. Okay, so I'm going to change the confidence to 99%. Okay, so you got 99% here. So your chance of being wrong is 1%, which is 0.01, and then it will calculate. See, everything has been calculated, and this is for the home fire question. So I'm just gonna copy it, Control C, and go to our main workbook and paste it right there below the question, and then we can make our conclusion right here. I can expand it, make it font size 16. So you can see the lower interval, upper interval. So again, these are 99% confidence. So we can say with our conclusion. So we can say with 99% confidence that on average, between 4,785, you can see right here. If you run it, then this is just typo. So between 4,075 to 9,297, 297.87, home fires are started by candles each year. Yeah. Any question on this one?
No, thank you.
Okay, no question. Okay, good. Now we have completed the confidence interval for the mean. Let's now look at confidence interval for proportion. Now, when we say proportion, we are referring to a part of something. Let's say 50% of 700. 50% is the proportion there. So we can make confidence interval for proportion too. Now, to do that, we need to understand the key terms we'll be using. those key terms are as follows. The proportion itself, which is the population proportion, P. Then the sample proportion, we call it P hat. Okay. Then we got the P hat is the formula is X over N. Sometimes P hat will be given as a percent sometimes. In that case, you use the percent to calculate it. Then Q hat is 1 minus P hat. Then you calculate the error margin using this formula here. Okay. Now, how do you find a critical value? For proportion, I'm going to copy this confidence levels. That is the way we use Z alpha over 2 for proportion. I'm gonna put this right here. Okay, for confidence interval for proportion critical value. I'll call it computing critical values. Critical values. Okay. Give me a minute. Let me write this down. Here. Yeah. Critical values. Values. Okay. So I'm gonna paste them here. Oh, excuse me, sorry. It's too large. So I have 999, 995, 90, 95. Okay. Now I'm gonna go back there. Okay. PMC. I think okay, 95, 99, 98. 99 and 98. Okay. Now we have for this we have alpha itself. Yeah. Alpha. We'll put alpha. Alpha. Then we got alpha over 2. Because you have two sides, left side and lower side and upper side. Then critical value value Z alpha over 2. So I'm going to which is what we are trying to find here. This is for proportion now, okay? All right. So let us look at this page because it says here that I have to find the critical value for proportion. Then we can do an example. Now, if you remember, what I said, if we're finding critical value for we are using Z, the formula is okay, num dot S dot inverse. Okay, 1 minus alpha over 2. Okay, we have put it right here. Go to this place. I'm gonna put the formula right there. Page I'll put it right here. Num dot S dot inverse. 1 minus alpha over 2. That's how you use to find the critical value for Z. If you're using the Z, again, you can see it. So I have it here as well. Find the Z critical value for any confidence interval with MS. Okay, that's it. Okay. Now we're ready to find them. Let's do it. Again, like I see, if you're 90% confidence, your chance of being wrong is 10%. So your alpha is 10% or 0.1. You're 95% confidence. The chance of being wrong is 5%. So your alpha is 0.05. Okay, same thing here, 0.01 and 0.02. So alpha over 2 is just to divide all of them by 2. So put equal sign. This divided by 2. Press the enter key. Give me this. And then I copy it down. Now let's find a critical value, which is the main thing we are looking for here. Again, norm, put the equal sign, then norm dot s dot inv, which is inv. It pops out, double click. 1 minus alpha. So 1 minus alpha over 2, which is right here, 1 minus this. Close parenthesis. Press the enter key. Then double click it to get the rest. And then, of course, you make it 2 decimal places. We normally use 2 decimal places. Yep. And that's our critical values right there. Yeah. This method I showed you last week, that is for Z. I'm doing it because we're going to need it for finding the confidence interval for proportion. So I'm going to copy the whole of this. I'm going to make it, bold it, then Control C and paste it here. Okay. In our main workbook, where we are working now, we are now on the confidence interval for proportion. Okay. Right here, I'm going to put it under here. Okay. Make it get this right here now. Good. Undo it. Undo it. Undo it. So I'm gonna go down here and then paste it. Yep, that's better. That is much, much better. And my next map. Okay, make it bigger. Make alpha. Good. Now that's how you find it. Now let's answer the for proportion. I have given you the key points. Let us answer one question there or two. It says here, in a random sample of 2 investment advisors, 7 recommended IT stocks. So give the maximum error with 95% confidence. Then construct the 95% confidence interval for the true proportion. So first of all, let us put down the summary statistics. First one is the N. N equals out of 200 investment advisors. Remember, this is small n. Small n. I'm gonna make this should be 18. Okay, small n. Out of them, then X is out of these 200 investment advisors, 70, which is X. Recommended IT scores. Part A says, give the maximum error of estimate. Okay. Error of estimate with 95% confidence. So let us get our p hat. Okay. Our p hat, I'm gonna put all these things down. P hat and Q hat. Let me put them up, put them down so we can put a number for them. So our p hat, this here. Our p hat is X over N, which is equal to make this 18 so it's more clear. S over N, which is S is 70 over N, and N is 200. Equal. Now you can get this from the calculator. 70 over 200. Where's our calculator? Okay. We have, okay, decimals. Okay, good. Let's share it. 70 divided by 200, 0.35, 0.35. 0.35 is the p hat. Then q hat is always 1 minus p hat. Always 1 minus p hat, which is make it 18. 1 minus p hat. And p hat is 0.35, 0.35. Okay. And get this on calculator. Okay, 1 minus 0.35, 0.65. Okay. That's 0.65. Now, so now next thing we need to find because we need the error margin, right? We need z alpha over 2, z alpha over 2. Look at the alpha. Alpha, okay, right, it's right here actually. Alpha over 2, z alpha over 2 equals, now it says we're looking for with 95% confidence. So for 95%, the critical value is 1.96. 1.96. And sample size is n. So these are the smallest statistics we need to calculate this the error. But say find the maximum error of 8 million. Now, I'm gonna write these smallest statistics here. N is 200. X is 70. P hat is 35. You see right here. And Q hat is 0.65. P hat is 0.35. Not 35, 0.35. Now, Z alpha over 2 is 1.96. Now we're ready to find the error. Now look at the formula for the error right here. It is Z alpha over 2 times square root of P hat times Q hat over N. I'm gonna just write it down and we can go and type it in. Error 8 Z alpha over 2 times square root of P hat.
Be lying.
Over N. Hello, you have a question on this? Okay, no question. Okay, I think so our error will be, well, inside this. Okay, error is E equals, I'm gonna make this to be bigger. It's to be 18 equals.
Or maybe you want to eat with us.
Yeah, because why would you
Hello,
fuck us in the cab and go eat in Raleigh?
Can you meet us? Can you meet yourself,
So
please?
if we was in the cab.
Hello, can you mute yourself? Can you mute yourself?
Oh.
Z got alpha over 2. Okay, we have alpha. What's the alpha right here? Gotta be somewhere, I'm sure. Alpha over 2. Okay. Times. Yeah. Okay, we have excuse me. I'm gonna try it again. Times standard deviation times the square root of, okay, we got p hat. P hat. Okay. Times Q hat. Over N. Okay, which is Z alpha over 2. We have our Z alpha over 2. Remember with our summary statistics? Z z alpha over 2 times square root of p hat and q hat over n. And we have them all here. N is 200, p hat is 0.35, q hat is 0.65, z alpha over 2 is 1.96. So we just plug them into that formula to get our error. Okay. I'll have z alpha over 2 is 1.96. Okay, times square root of p hat is 0.35. Okay, times the q hat is 0.65. But n is 200. So we gotta put this on a calculator. E equals 1.96 times square root of 0.35 times 0.65 over 200. So let's go and put this in the calculator. Okay, have 1.96 times square root of 0.35. Okay, excuse me. Times 0.65 over 200. 0.066 equal to 0.066. Okay. Have it right here. 0.066. So I'm gonna copy this and put it in our main workbook. So we answered part A basically, because this is part A. Part A asks us to find the maximum error of the estimate. Give the maximum error with 95% confidence. So part A, that's why we're gonna put this under this. So maximum error is 0.066. Now, with this, we can find the 95% confidence interval using this formula here. P hat minus error less than P hat plus. So on the left side, you subtract error. On the right side, you add error. Our sample mean is sample mean X bar. Say that sorry, not sample mean. This is supposed to be P hat. P hat is 0.35 already. So you're gonna have here 0.35 minus error of 0.066 less than P. Okay. Less than P. Less than 0.35 plus error of 0.066. Now, I'm going to write this here so we can get it from the calculator. 0.35 minus 0.066 and P 0.35 plus 0.066. So this will give us the final result of this. Now, 0.35 minus 0.066. Can get that from calculator. 0.35 minus 0.066 is 0.284. Okay. 0.284. And on this side, we're gonna have 0.35 plus this. So just go over there and put plus sign, that's all. It will give us the results. Change this to plus 0.416. Okay. 0.416. 0.416. So this 0.284 is the same as 28.4%. and this one is the same as 41.6%. So we are 95% confident that between 28.4% to 41.6% of investment advisors recommended IT stocks. Any question on this? So no question. Good. Now remember, here we are not given the p hat. We have to calculate it by ourselves using this formula here. But in some question like this one, we are given the p hat as 12%. So you don't have to calculate p hat. You just put p hat. I don't know if it won't allow me to put it here, but I'm going to write p hat. In that case, p hat. Oh, excuse me. P hat equals 0.12, and Q hat. Okay. Q hat. Sorry, mistake. Q hat equals 1 minus p hat. P hat, which is 1 minus 0.12, and then from the calculator we can get 1 minus 0.12, 1 minus 0.12, 0.88, 0.888. So now you use it to perform instead of using p hat equals s over n and calculating it by yourself, you just put p hat equals 0.12 and q hat equals this, and then do the same process again. That's the only difference between this one and the other one. In the other one I just did, p hat is given and this one is not given. When it's not given, you calculate it using the formula x over n. But if it's given, you don't use, you just type it in basic. Then apply this formula to get the error, and then get your confidence interval. Now we can now round up with how to calculate the sample size, computing the minimum sample size. In this case, we use this formula here: p hat times q hat times z alpha over 2 over error.
Excuse me, Mr. Dr. Oji.
Yes, ma'am.
I thought class ended at 3:30.
Class end at 3:50, not 3:30. I'm just ended at 3:30 if we finish on earlier, but it end at 3:50. Check the syllabus. Okay.
Okay, my bad. I just have a question to ask after class.
No, it's a good question. It's a good question.
Oh, no, I have like a different question to ask after class.
We're almost done. When we finish,
Okay.
you can ask, okay? We're almost done.
Thank you.
Welcome. So now, I just want to show you how to get this one done, and then we'll be good. The sample size is n plus p hat times q hat times, you multiply these two and square it just to get the sample size. For example, I'm going to do this with one example here, and we are done, okay? Now, it says here that a researcher wishes to estimate with 90% confidence the proportion of people who own home computers. A previous study showed that 40% of those who interviewed have a home computer. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. Again, the formula is right here. So first of all, we need to find the p hat. But unfortunately, this will not allow me to put p hat here. Okay. Maybe I can get it from the other list. Let me see. Let me the p hat. P hat. In this case, p hat is given as 40%. Okay. So I'm gonna get it right here. Try this. Okay. In that case, we have p hat. 40% is 0.4. Now, q hat. Okay, let me take this first of all. And then we can go and paste it right there. Then q hat, 1 minus p hat, always 1 minus p hat. Q hat, which is this. Q hat always 1 minus P hat. P hat. So they told us that P hat is 40%. So Q hat will be 1 minus 0.4 0, which is 0.60. Copy this and paste it right there. Okay. Now we have them. So remember, I was explaining that sometimes they give you the P hat as a percent. That is, we don't have to start doing S over N. So this one they give us as a percent. Just put P hat Q hat. Then next we need to put is the Z alpha over 2. Z alpha over 2. Z alpha over 2. What's that? Alpha? Alpha right here over 2 as a critical value. But again, we did that for 90%. We did it here. Remember, we got it as 90%. Critical value for 90% is 1.64. So we go and put it right there. 1.64. 1.64. And in that question, you say that there is such a one to be wishes to be accurate within 2%. That means the error is 2%. If the error margin is 2%. So our error E equals 2%, which is 0.02. Now, all this we plug into this formula to get the sample size we're looking for. We plug it right here. The required minimum sample size, the minimum sample size then is, use the formula here. Okay. Now, let us go and put this formula in Excel, and then I'm going to write down this formula. We have P hat, the summary statistics. P hat is 0.4. Q hat is 0.60. And Z alpha over 2 is 1.64. E is 0.02. Let's go and put this in the other book and calculate the minimum sample size. Okay. Okay, I'm gonna put it right here. This is okay. I'm gonna move this so we have enough room. I'm gonna make it bold, make it 18. This will give us okay, equal. So P hat. Remember our P hat, the summary statistics we have. Our P hat is 0.4, Q hat is 0.6. Z alpha over 2 is 1.64, and the error is 0.02. You can just go plug them in. So we have P hat is 0.4 times Q hat is 0.6. 0 times, now I have this Z alpha over 2 squared. So I'm gonna put this, then put parentheses for them, and then put the fraction part. So we have Z alpha over 2 is 1.64 over error 0.02 all squared. Okay, equal. So I'm gonna unbold this boldness, man. Well, make it 16 and unbold it. So we have it here. Let me put this on the calculator and we get our answer. Got 0.40 times 0.60 times 1.64 over 0.02 squared. Now let's put it in, and then we have 0.40 times 0.60 times Okay. 1.64 over 0.02. Okay, all squared. It give me 1613.76. So we can go and put it on our work. We got 1613.76, which normally we round up to the whole next whole number, which is 1614 samples. That's what we need. 1614. We always round it up to the next whole number. I'm gonna copy this and paste it right here. Okay, paste it right here. So you can so now that's how you find the minimum sample size for proportion. Any question before we finish? We are done actually. Any question?
Yes.
Okay.
So it's for the assignment, one of my makeup assignments.
Yes.
I'm just having a bit of difficulties in Excel. So with binomial probabilities, because that's what I'm working on right now. With the binomial probabilities, when I'm entering the equation, so the equal sign binom dot dist, I was following your video and I was inputting the numbers correctly. And after I close the bracket, like put the last parentheses, it's telling me that I entered too many arguments for the function.
Probably did. Let me see an example here. If you enter too many arguments to say that, yes, that is probably maybe there's a slight mistake. I'll use an example here. Let's say that n equals 25, for example, or equals
Yeah,
25.
because the question was if the probability is 0.25 that a new small business will survive beyond its first 3 years, use Excel to find the probabilities that among 12 businesses selected at random.
No,
That was the question.
it can be among 12. It can be either, I say at least. It can be more than, yeah, probably, I think you are mistaking the question. Let me see if I have it here. I don't know if I have it here with me. You're talking about the makeup assignment, right?
Yes.
So let me see, we can put it from here. 1 minute. Makeup. Okay. So if it says at most, you say find that among the 12 businesses, at most 4. At most. So the end given was 12. So okay. Now I'm giving you an example here on the screen. Just watch
So what do
my
you mean at most? Like, because I put for the equation, like I'm confused. I put for the equation
that's
n
what I want to show
equals
you.
12,
That's what I
and
want
then
to
I
show.
put p equals 0.25.
That's why I want to give you an example here.
Okay.
First of all, is to find put the n and x and n and p. P equals, let's say my p is, let's say that my p is 0.3. Okay. And my question was at most, let's say my question is at most 5. Okay. What I normally do is n is too big here. Let me say that my n is 10. So now I'll get all the x's to 10,
Yeah, I got that out of the way.
0 all the way to 10. Okay. 2, 3, 4, 5, 6. Guys, we have class is over. If you are free to go, I'm just showing her something. 5, 4.
Have a good one.
You too, sir. 2, and then 1. Oh, my mistake. 5, 6, 7, 8, 9, 10. Okay. Now, next is that RPX. Okay. So normally I get all the probabilities first. So I'm gonna use binom dot dist. It will pop out right here. Double click on it. Our numbers is right here. Click on it. Comma. Trials. 10 trials. See? We see our n is 10. Comma. Probabilities. Is p, which is 0.3. Comma. Then for the this cumulative, use false. Type false.
Yeah.
Then close the parentheses. And then press the enter key. Then calculate. Then follow it. So if you follow it this way, there's no way you can get it. Now, this is how to
I
get.
did follow it that way, and it's giving me I told you it's giving me, it says I've entered too many arguments for the function, so I'm just confused on what I did wrong. Like,
Yeah, that's what I'm explaining to you now. There must be something that you type. If you follow it exactly, now there is it will come out. There must be something. Maybe you typed in a comma somewhere without my mistake. You go and check it again. There must be somewhere that you typed something twice, or maybe a comma by mistake, or full stop, or something else. There must be. That's why it says that. Now with this, you get it. Then if I say at most 5, for example, if I'm looking for probability of, okay, if I say at
yeah,
most,
I could follow the rest of the video fine.
okay,
It's just that part.
this part, yeah. Okay, just
Yeah.
let me do it again. Equals binom
Okay.
dot dist. So dot dist. Okay. Parenthesis. Numbers. Make sure that your numbers are, click on this. With comma. Trials. How many trials? N is 10. That means 10. Comma. Probability is 0.3. Comma. Then cumulative. Make sure you type in false. Then close it. That's it. Press the enter key now to give you this. And then you can copy it down. So do it. Go.
You did the first X, then you did the probability, then N.
So
Okay.
go and double check it again. Make sure that you're not typing something else by mistake. And that's it. Okay.
It's still, well, now it's
Leave it alone for now. Okay. Leave it alone for now. Then maybe next 30 minutes, come back to it. Watch the video again. Then try it again. Okay.
okay, thank you.
You're welcome. Man. All right, guys. Have a nice day.
Hello, Professor. I
Yes,
had
ma'am.
one thing to say. I sent you an email. I just wanted to know if you could look at the email I sent you.
The email is about.
It's about a past assignment that was due.
Are you talking about the makeup assignment that you want to redo?
I'm sorry, repeat that.
Did you send email about makeup assignment? Is that what you're saying?
No, it wasn't a makeup assignment. I sent you this email probably yesterday or 2 days ago. I already sent you an email regarding.
What's your name? What's your name?
Kendi, Kendi.
Okay, I will check it out. Kendi,
Okay.
Kendi Holland?
Yes.
Okay. I'll share the email.
Okay, thank you.
You're welcome. All right, guys, have a nice day. Class is over.